I wanted to have an opportunity to talk a little bit about some structural elements that we can put in our model. So what I've decided to do is add a floor system. We're going to add two floor systems, one for the base of the floor system, which will be the same as us adding a slab that we've done in a residential project. We're not going to go too crazy with any foundation systems on this one since they're pretty much the same as a residential application. But I do want to take you into the areas to know and understand how to create a beam system or floor truss system for the second floor. So let's begin with the easy part. I'm going to go to level 1 existing. The reason I'm going to level 1 existing and not level 1 is the floor system I'm about to put in here is an existing floor system. So I want to be in the level that is set up for the existing phase. Okay. We'll go under floor, and I just want to create a 4-inch concrete slab that we'll put in the basement. So it doesn't look like I have a 4-inch concrete slab in our choices here, so why don't I pick actually I think this is what I'd like to pick. This VCT on 4-inch concrete slab would be perfect. So VCT stands for vinyl composition tile, and for an office application that might work just fine, especially for our existing conditions. So let's go ahead and grab that, and we're going to grab our walls and place that information in our model. Oops. Now the slab should go right out to the edge of the model, so I'm just going to push that pink line to the outside, and then we'll just hit OK. Okay, so if we go to our 3D view, because the 3D view is also set to show existing conditions, we're able to see our vinyl composition tile added to our model, and we can see our slab sticking out on the bottom. And that's all we're going to do with our floor system for now. So now we're going to get into creating a structural floor system in our level 2. So I'm going to double click on level 2. And we already have some underlays and everything set up for us, so you can see all of our first floor information. This is going to be our bearing wall. So I'm going to change this type of wall this is, and I'm going to make it the largest interior partition we can make. Of course, if you know, I'm not a structural engineer, but I'm just showing you the types of framing systems you could put in here. What I pick for floor framing, I'm going to go ahead and say I haven't looked it up to see if it would actually work with the span, but it will give you an idea of how to find this stuff if you knew what you were looking for. So I'm just going to change this to interior 6/8 of an inch partition. If we found out that needed to be a stronger structural member, then obviously we would use something else, but we're going to go ahead and use that. And what I want to do is I want to have floor trusses spanning from here to here, and then spanning this distance from here to here. And then on top of the floor trusses, we will put a metal deck and concrete floor system. And then we will create a roof system and actually have it slope towards this center wall, so that there could be roof drains in this floor system. We'll also add some columns in this wall to help support the floor framing and roof structure. All of the rest of the walls that are inside this area and this area are non-bearing walls. There are going to be all partition walls that go up 9 feet, and then our dropped ACT will be at 8 feet. So these partition walls won't even go all the way up to the roof deck. Just the one partition wall or bearing wall in the center will go all the way up to the roof. And I think I have it set up that way right now. Actually, I don't. So it should say base constraint level 1, and then actually when we create a roof system over here, we'll end up having that expand all the way up to the roof. All right, let's begin with the floor system. So under the Structure tab, what I'd like to do is create a beam system. So I'm going to click on the beam system, and I'm going to go ahead and draw what I'd like to where I'd like to have that beam system located. So I'm going to use the rectangle command, and I'll just start off by drawing that to the outside and have that go to about the center of this wall here. And if I have to break out of the, there we go. Well, I'll do that, and then I'll move this line out to the outside. That I may have to adjust that, but that's good for now. Now these lines here indicate which direction the floor framing is spanning in, or beam direction. I want to change that beam direction. By clicking on beam direction, I can change it to that direction instead, so our beams are going to go this way. If I go ahead and hit the checkbox, you'll see that the beam type that's going to be used automatically is W wide flange W12 by 26. I'm going to show you what that looks like. So if we hit the checkbox, we end up having those beams labeled, and then when I hover over it, I get kind of a dash grid that shows me where those beams are going to be located. Let's go ahead and take a look at a section so we see what happens when we look at it in section. So I want to draw a section that goes from here to here. And we'll double click to go into that section view. And in order for us to be able to see all the structural elements, I want to do a few things. Well, let's do it first and then you'll see what happens. I actually want to look at this as a structural section. So I'll go down here, the section that I just created, and I'm going to right click and rename it structural section. Let's try caps lock here. Okay. Now, if I want that to show the structural elements, I need to change my discipline here from architectural to structural and apply. Once I do that, then it's kind of surprising that all of these walls kind of disappear, which is seems somewhat scary. Where did our walls go? But we're going to fix that by indicating which walls should be bearing walls within our wall systems. So I'm going to go back to that plan view, the existing plan view, and I know that this is a bearing wall, this is a bearing wall, and this is a bearing wall. So I'm going to select the two on the outside, which are the same, by holding down the control key. And if we scroll down, you'll see there's a section called structural in your settings. We want to change structural by or we want to check off structural here, and then structural usage, we have three choices: bearing, shear, and structural combined. I'm going to keep that as bearing because this is bearing the weight of the floor joist, as is this, and this will also be a bearing wall. The wall in the center, I want to do the same thing. I want to change that to a structural wall, bearing. And then when we go back to that section view, you're going to see the beams that we had beyond. Let's try find to see that, and we'll change this to a quarter inch equals a foot at least. So those are the beams that we have beyond, and there are our bearing walls that were not showing up there before. Okay. Remember that our structural section is set up for new construction phase. So if I were to start drawing anything in here, it's going to show up as a new construction element. For now, we may want to look at this structural section as an existing conditions, and then our line work and our information is going to come in as solid walls. Now, notice that our beam disappeared. The reason for that is when we created the beam system in level 2, we did create this in a level that was set to phase new construction, so that new beam system is considered new construction. So I'm going to change the phase created to existing, and then when we go back to that section view, we should be able to see the beam back in place. Okay, so that's pretty straightforward. Now, what I'd like to do is I would like to change a few things about the wall system. We'll keep the level 2 at, I'm going to change actually level 2 to 12 feet. And I'm going to add a roof level. So we'll go to architecture and add a roof level here. Rename that roof. And we'll set the roof level to 22 feet. So we have 10 feet for the second floor. Now I can take all of these walls, and I may want to do this in my level 1 existing. I'm going to select all of the exterior walls plus this interior wall that we're using as a bearing wall, and I want to change all of them from unconnected to up to level roof. Okay, and then we go back to our section view, and that's perfect. Okay. So now what's going to happen is I want to swap out this beam, which is just a W-wide flange beam, for a K-series floor truss system. So we need to go back to the level 2 plans. I'm going to select the existing beam series that we have, and you can see that we can swap out here a different size. Okay, but the K-series beam is not available in this list, so I have to download it. I'm going to go to Insert, Load Family, and if we scroll down to the structural framing section of the list, we have steel, and if we look at the list, we have a K-series bar joist angle web and a K-series bar joist rod web. I am not sure of the difference between these. This is where my ignorance comes in with structural stuff, but just pick either one of these and I think you're going to get the same choices as far as sizes go. So I'm going to pick, say, this K-series, and then I'm going to locate. I want to have a 26, 20K6 K-series, and I want a 14K6 or 16K6 rather for the opposite side. So I might as well bring those in now. So now those are loaded, so I should now be able to select my beam system, and then under beam type, or across from beam type rather, I can swap out for the correct size. So this is the larger span, so I guessed about a 26 K-series, and if we swap to our 3D view, not 3D view but structural section, we can see there the new K-series beams there, our floor trusses, and then on this side I'm going to create just another beam system in level 2, and we'll go under structural, new beam system, and I'm going to create similar layout for the beam system that we had before. I will have to move this to the existing phase. We want to change the direction, and I should be able to swap this out for the correct size, 16K. Perfect. Alright, and then I'm going to hit the checkbox, and then these I have to make sure are on the correct phase. So they say phase created new construction. I want to change that to existing, and we'll go to structural sections. Perfect. So this is a slightly smaller floor truss system because it's not spanning quite the same distance, and I just also wanted to be able to show you how you could get multiple types. If we go back to that insert and load family, just to show you how many other options we have on that structural framing, we have concrete, light gauge, steel, precast, steel, and wood. Just in the steel section, there's also an ASIC 14.1, which have all the other types of shapes that are the standard stock shapes for our steel structural elements. W shapes are the ones that are already loaded. If you go into W shapes here, you'll see that you have tons of choices that come right from the structural catalogs. Okay, so on the sides here and here, we would need to have a I-beam supporting those trusses. So I'm going to add those elements to our level 2, and I'm just going to, for now, change this to existing as well, so I don't have to keep switching it over. And we'll go under structural, and this time I want to create a beam. And for beams we have W shapes, W wide flange shapes, And I think that the sizes that we have in here aren't quite right for our application. Let me just try the 2144 and see what it looks like. That would go right down the middle here. We'll go to our section view and see if that shows up. Oh, I guess that's pretty much the right size, isn't it? And I would have to make some adjustments to where this fell, as opposed to, this beam should be down below this one, in other words. And there would be a little bit more involved as far as getting this in the right place in the wall and things like that. But I'm more interested in just showing where to find this information. So we'd have one in here as well, and we'd have some columns below it. So let's go to our existing one level and we'll add some columns. So let's try columns. We go to columns. I have a wide flange column that's 10 by 48. Let's see how big that is. I want the column to fit inside the wall. So I think I've got to go load structural columns, steel, and I want the W wide flange column. And I want to pick pretty close to the bottom here. I want to try a wonder if 6 by 9 or W5 by 16. I'm trying to remember what I picked before. I think, yeah, this one would fit in the wall, and so I was looking for ones that would fit in the wall. That's a little bit too big. So columns, steel, go all the way down to the bottom. Maybe it was this one. Yeah. Let's see if this got changed. That's 6/8 of an inch partition. I'm wondering now if I change that to even larger. Anyway, let's keep going with this, and we can adjust the column size, or we fur around the column for that that wall. All sorts of solutions for that. So if I go to the 3D view, where that column landed is right here. And I want to change it so that it goes from it goes to the roof from level 1, and of course there would be pads underneath here and everything, but we're not going to get into that type of stuff for this. I just wanted to again just show you how you can put the structural elements in here, and then we can pick where we want that column to start from. Maybe from the center of this wall we want to go over 8 feet, and then we could take that column and array it. So I'll use the array tool. Let's say we need 10 of them, and I would pick from the center of this wall to the center of the column, and I'm just going to delete the last one that landed on the outside. If when you do this you end up having an interference with this door, go ahead and just move the door over a little bit so it's in between the columns. I'm going to just look for one more column type, because I'm pretty sure I found one that fit in the wall, and I think I'm just not looking in the right place. I think I grabbed the smallest one, didn't I? 4 by 4. Structural columns. Oh, that's why it was happening. We didn't actually have the column selected. That was the one. So I'm going to select this one column, select all instances visible in view, and I want to swap this column out for cancel. Oh, I guess I don't want it to be part of the array group. Ungroup. So I want that column to be swapped out for, see, I knew it was 5/16 would fit. Okay, there, that does fit in the wall. Now I want a beam that goes across here, so I would pick the beam, and let's put the beam in here from here to here. And when we go to that structural section, we should see, oh, we don't see the beam. Oh, there it is. It's down here. We don't want it down there. We want it up here. So we'll put that beam in at the second level and then put another one over here too. So I'm going to go back to that level 1 existing, and level 2 rather, and grab the beam here. I should be able to tab through and find that beam. Is that it? No. Let's try it this way. Filter, structural beam systems. No, that selects the whole thing. So maybe I want to do it from this section. So let's take that beam and I'm going to mirror it to the other side. A little bit too far, but we can bring it over like this. Good. And I guess the same one, we want the same one to show up in the middle. If you wanted to get a different size, you can go grab a different size. Alright, so that is our structural information for our section, and we're showing how we've got a bearing wall here and our bearing walls on the side, and that our floors are spanning that distance. So now we're ready to put our concrete on metal deck floor system in here. So we'll go into that second floor, which has been swapped out for existing conditions already, and let's go to floor structural. And in floor structural, we do have the 3-inch lightweight concrete on 2-inch metal deck. And I will pick walls that, actually I'll do rectangle because I want the floor system for the metal deck to go across to here. And I want the other one to do the same thing on the other side. So we'll do floor system, same one, create a rectangle. And I may need to go in and adjust exactly where the boundaries are, but you get the picture. Let's go to our section, and we'll see that the metal deck is a little bit too low. So the metal deck is showing up at the first floor. Technically this should be below that. You could put in some offsets. So we have a Z offset right here. If we put in -3 inches, I think, or is it -4? You can start to kind of control where those K-joists are. Actually, that ended up just moving that one, so you don't want to do it that way. So we know we want to move it down 4 inches. So let's go back to the level 2, and I'll select the 2 beam systems, and we want to work plane. Let me see if I can change or edit work plane. Edit work plane. We may want to create a top of floor joist work plane and attach it to that. So let's go to our level here. Create a new detail, or not detail, but a new level. So this will be called top of truss, and it should be set to 4 inches below, or let's align it even better to the bottom of this. We'll lock that. And so this now, the work plane, I should be able to change it. Oh, I have to do it from that top view. Just got to be in the right view here. So let's select both. See if I can pick both of them at the same time. Edit work plane, and I want to set both of them to top of truss. And that should do it. Let's just see if it worked. Perfect. Okay, so this should also have a new work plane set for it, or we should change the level that it's at. Work plane level, So it looks like I've got to do that in the top view as well. They don't make it easy sometimes. I think you get the picture, so I won't bother with that. All right, so I think we've got our floor system. So the last thing we're going to do is add a roof system, and this is a really cool roof system you can create that actually has tapered insulation. So if I go to roof, within this, because we started with a commercial example instead, we have a steel truss insulation on metal deck EPDM. I'm going to take that and I'm going to edit the type and duplicate it and just call it steel, or I'm going to call it just metal deck, steel truss metal deck. And you'll see why here for a minute. So I'm going to do that, okay? And in here I'm going to get rid of this thermal layer and this roofing EPDM, okay? So it's going to have that. And I'll put that roof system in based on where the walls are located. Now this roof system, I don't want any slopes defined. So I'm going to select all four sides and turn off define slope and then hit the checkbox. Then I'm going to go back to that original roof system, edit type, duplicate it, and call this just insulation and EPDM. Okay? And then we're going to get rid of, let's put these two things inside the core boundary, and I'm going to get rid of the two structural pieces in here. And these are the thermal layer, okay? And I want to pick the same, did I just end up changing that one? Oh, I don't want to change that one, so let's change that back to metal steel truss deck, okay. And then we'll to roof again, and this time I should have this one, and I can pick the lines of the existing roof that were here. Again, I don't want these sloping, so turn off define slope, and we're going to end up having to put an offset on that, but we'll look at that when we look at it in plan, or in section rather. So we can hit the checkbox. All right, so let's look at that in section. There's the insulation layer, there's the steel truss layer. So I want the insulation layer to be aligned with this top edge. Perfect. And then I want to be able to taper this insulation to the inside. And I'm actually going to change the insulation thickness. I want it to be a bit thicker than that. So I'm going to change that to 8 inches of insulation. I think should do it. And then we can taper it in the middle. So here's where the tapering part comes in, which is really pretty cool. There's our, I've obviously got to fix some of this stuff that's sticking out, but you would know how to do that, just edit the boundary. All right, so I want to see here a taper that will be right along where the bearing wall is. So I got to locate where that bearing wall is. Is that the bearing wall in there? I think it is. That's the west elevation. Let's find out. We'll go back to the existing level. That is the south elevation, so the bearing wall should be back here. So if we go back to that 3D view, the bearing wall is oh, right there. That makes sense. All right, if I select that top layer of roof, I can add a split line, and I'd want to add a split line right about where the bearing wall is, okay? And then now that I have a split line, I can take this, I can modify this point, and I can put in a negative value. So I'm going to put in negative 3 inches, and that's going to taper the insulation towards where we might have roof drains. And when we look at that in section, we have a perfect example of the straight structural elements, but then the insulation above is tapered. Now it does technically taper the bottom as well, and it shouldn't taper the bottom. It should keep the bottom intact and only pull down in the center. I haven't quite figured out how to fix that yet, but it does give us the effect of the flat roof sloping towards the inside to create our tapers. If we wanted to, we could create a curb sweep that would go around the outside of the building and add that as well. So now we've basically added a second floor, a mezzanine level, and we end up having the first floor, and we have some real structural elements in here. So that's kind of what I wanted to show you how to do, how we could add those structural elements in there. Kind of a long video, but there you have it.